Today we will discuss an important topic. What is electric dipole and dipole moment? Electric dipole. A system of two equal and opposite point charges separated by a small distance a system of two equal and opposite point charges separated by a small distance is called an electric dipole. Okay, two equal and opposite charges separated by a small distance is known as electric dipole. So suppose these are 2 point charges minus q and plus q. They are separated by a distance 2a. Okay, so this constitutes an electric dipole, and this is the dipole moment P. Okay, so this is electric dipole. Two equal and opposite charges separated a small distance is known as electric dipole. तापरे आमे देखिबा इलेक्ट्रिक डाइपोल मोमेंट. इलेक्ट्रिक नेक्स्ट हम देखिबा इलेक्ट्रिक डाइपोल मोमेंट. Okay, electric dipole moment. So electric dipole moment kono? Now the strength of a dipole is described by a vector P. Is described by a vector P called the electric dipole moment. Called the electric dipole moment. Okay. The magnitude of dipole moment is equal to the product of either charge and the distance between the charges, and distance between the charges and its direction, is from minus q towards plus q. Okay, so this is dipole moment. The strength of the dipole is described by a vector p called the electric dipole moment, and the magnitude of dipole moment is equal to product of either charge and the distance between the charges, and its direction is from minus q to plus q. So the magnitude of dipole moment equal to q into 2a. Okay. It is directed from the negative charge to the positive charge. Okay. The direction of the dipole moment is from negative charge to positive charge, and its unit, the SI unit of dipole moment is coulomb into meter. Okay, जेहेतु तुम डाइपोल मोमेंट इक्वल q into 2a, q रो यूनिट होची कूलम and 2a रो यूनिट होची मीटर. So the SI unit of dipole moment is coulomb into meter. Okay. So very important long question we will discuss. Electric field strength, electric field strength or intensity due to an electric dipole. Due to an electric dipole at any point on the axial line end-on position. Okay. Suppose in the axial end of the dipole there is a point is present, then we will calculate the electric field intensity due to the electric dipole. Okay. Suppose this is an electric dipole consisting of two charges minus q and plus q. This is the center of the dipole. Okay, this is point P and this is point A. Dipole length is 2A. Okay, suppose this is the axial end of the dipole. This is point P. At point P, we will calculate the electric field intensity due to the electric dipole. Suppose the point P is situated at a distance r from the center of the dipole. Okay. So electric field strength at point P due to charge plus Q, as this is a positive charge, so the E1 is along this direction. Electric field strength at point P due to charge plus Q is E1. Okay. Similarly, electric field strength at point P due to charge minus Q. Okay, as this is a negative field, negative charge, so a attractive field acts along this direction. Okay, so this is your repulsive field and this is your attractive field. We will calculate electric field intensity at point P due to the dipole. Okay. So consider an electric dipole consisting of charges minus Q and plus Q. Okay, situated, so minus Q is placed at B and plus Q is placed at A, situated at B and A respectively, situated at B and A respectively, separated by a distance 2A. Separated by a distance 2A. Okay. So consider an electric dipole consisting of charges minus Q and plus Q, situated at B and A respectively, separated by a distance 2A. Okay. So let P be a point situated at a distance r from the center of the dipole, where we have to calculate the electric field strength. let P be a point situated at a distance r from the center O of the dipole on the axial line where we have to calculate the electric field strength. Okay, at point P, we have to calculate the electric field intensity due to the electric dipole. So electric field strength at point P due to charge plus Q. What is the electric field intensity at point P due to charge plus Q? 1 by 4 epsilon Q by distance square AP square. So AP equal to kete ita asla purada hochi R etika hochi A. So AP equal to R minus A. Okay. So therefore electric field strength E1 produced by charge plus Q at P is given by E1 equal to 1 by 4 pi epsilon 0 into Q by A pure square. Okay, and direction of E1 is along, since this is positive charge, so a repulsive force acts along the direction of AP. Okay, along AP. Along AP produced. Okay. Or E1 equal to 1 by 4 pi epsilon 0 into Q by R minus 0 whole square along AP produced. Okay. So this is your question 1. Similarly, electric field strength E2 produced by charge minus q at P is given by E2 equal to that. So electric field strength at point P due to charge minus q 1/4 q by distance square bp square. So bp equal to r plus a, so q by r plus a square. This is a negative charge, so the attractive field acts along this direction, along pp. Okay, so E2 acts along pp. E2 equal to 1/4 epsilon 0 1/4 epsilon 0 into q by bp square along pp produced. Okay, or E2 equal to this 1/4 epsilon 0 into q by r plus arrow square along pp produced. Okay, this is equation 2. So the net electric field intensity due to the dipole, so the net electric field intensity or resultant electric field intensity, so the resultant electric field strength due to the dipole at point P is given by E equal to E1 minus E2 along AP. So if two vectors are acts along the opposite direction, then the resultant electric field intensity, then the magnitude of resultant electric field intensity is equal to the difference of the two vector, and the direction of resultant electric field intensity is towards the direction of a bigger vector. Okay, so since E1 is greater than E2, therefore the resultant electric field intensity acts along the direction of E1. Okay, or E equal to this or E equals E1 equal करते हैं हमारा E1 equal आस्ची 1/4 q by r minus r square, and E2 equal करते आस्ची 1/4 q by r plus r square. So putting the values of E1 and E2, so this is equal to give it equation 3. Okay, so substituting equation 1 and 2 in equation 3 we get. Okay, so E equal to so 1 by 4 pi epsilon 0 into Q by R minus R whole square minus 1 by into Q by R plus R whole square along AP produced. Okay, or so Q by 4 pi epsilon common, Q by into 1 by okay. So or E equal to Q by 4 pi epsilon 0 okay, or Q by A plus B square minus A minus B square equal to 4AB. So this is equal to 4AR divided by R square along AP produced. Okay, or we will rearrange the terms of above equation, or E equal to 1 by 4 pi epsilon 0 1 by 4 epsilon 0 to 2 into Q into 2A into R divided by along AP produced. Okay. So since P equal to electric dipole moment P equal to Q into 2A, since P equal to Q into 2A, it's the electric dipole moment. So the above equation becomes so 1 by 2 by along AP produced. Okay. So this is the expression for electric field intensity due to the electric dipole. Give it equation 4. Okay. So if the dipole is short, if the dipole is short, that is 2a is less than and less than equal to r, then a square can be neglected as compared to r square. Then a square may be neglected as compared to r square. So E equal to, from equation 4, so 2pr a square neglected, so r square equal to r fourth, 1 by 4 by epsilon 0 into 2pr divided by r fourth along AP produced. Okay. Or two P by RQ along AP produced. Okay. So this is the general expression for the electric field intensity due to an electric dipole on the axial line. Okay. So equation 5 is the expression for electric field intensity due to an electric dipole on the axial line. Okay, this is a very important question from the exam point of view. So E equal to 1 by 4 pi epsilon 2 pi by r. This is the expression for the electric field intensity due to an electric dipole on the axial line. So if on the axial line of the dipole a point is present, then what is the electric field intensity at this point due to the electric dipole? So the electric field intensity is found to be 1 by 4 pi epsilon 2 pi by r cube. Okay, thank you.